Okay, this is going to be the next video in our lesson on the binomial theorem. Okay, all right, we're going to pick up with Pascal's rule. Okay, so for the seventh, here would be the coefficients 1, okay, plus 7, okay, plus 21, plus 35, plus 35, plus 21, plus 7, and then plus 1, okay? All right? Now, I would start with 2x to the 7th, negative 5y to the 0, 2x to the 6th, negative 5y to the 1st. So I got to make sure that I treat that with the negative in there, okay? So 2x to the 5th, negative 5, y to the 2nd, okay? 2x to the 4th, negative 5y to the 3rd, okay? 2x to the 3rd, negative 5y to the 4th, 2x to the 2nd, negative 5y to the 5th, 2x to the 1st, negative 5y to the 6th, and 2x to the 0, negative 5y to the 7th, okay? All right, now, we can cross off the ones with the zeros, okay? So let's just worry about the ones. 1 times 2 to the 7th would be 128, x to the 7th. This next one, I would type in 7 times 2 to the 6th, okay? Negative 5 to the 1st, that's negative 224, x6, y1, all right? Then I got 21, 2 to the 5th, negative 5, all right, to the 2nd, 16,880, or 800, x5, y2, all right, 35, 2 to the 4th, and then negative 5 to the 3rd, it's negative 70,000, x4, y3, okay, 35, 2 to the 3rd, negative 5 to the 4th, 175,500, x3, y4. I'm going to go ahead and block that off. Okay, 21, okay, 2 squared, okay, negative 5 to the 5th, negative 2, 6, 2, 500, all right, x, 2, y5, okay, 7 times 2 to the 1st, negative 5 to the 6th, 218,750, x1, y6. This one I know is going away, so I got 1, negative 5 to the 7th, negative 7, 8, 1, 2, 5, y7. Okay, so pretty big there. Okay, all right. All right. Okay, now we're going to the 5th on this one, a little bit easier. So I got 1, all right, plus 5, plus 10, plus 10, plus 5, plus 1. Okay, so I got 4x to the 5th, negative 3y to the 0, 4x to the 4th, negative 3y to the 1st, 4x to the 4th, negative, to the 3rd, negative 3y squared, 4x to the 2nd, negative 3y to the 3rd, 4x to the 1st, negative 3y to the 4th, and then this would be 4x to the 0, negative 3y to the 5th. Okay, all right. All right, so 1, 4 to the 5th. I I know that this goes away here. So that's going to be 1024 x5, okay? All right, plus, actually, let's hang on that plus. Okay, so 5, 4 to the 4th, negative 3 to the 1st. Negative 3, 8, 4, 0, x4, y1. 10, 4 cubed, negative 3 squared, 5,760, x3, y squared. Okay, 10, all right, 4 squared, negative 3 to the 3rd, negative 4, 320, x2, y3. And then 5, okay, 4x, 1, negative 3 to the 4th. Hold on. All right, 1620, x1, y4. This goes away. I got 1, negative 3 to the 5th. Negative 243, y5. Okay? See what other one we got? Okay, we got this one to the 6th power. Okay, so you got to be careful. This is a negative 1x. Okay? So for the 6th, it goes 1, 6, 15, 20, 15, 6, 1. Okay? All right, so 3 to the 6th, negative 1x to the 0, 3 to the 5th, negative 1x to the 1st, 3 to the 4th, negative 1x squared, 3 to the 3rd, negative 1x to the 3rd, 3 squared, negative 1x to the 4th, 3 to the 1st, negative 1x to the 5th, 3, 0, negative 1x to the 6th. Okay? So I know this can go away, that can go away, and then that can go away. All right? So all I'm doing is typing those into the calculator. All right? So 1, 3, 6, that's 729. 6, 3, 5, negative 1 to the 1st. Negative 1458, x1. Okay, 15, 3 to the 4th, negative 1 squared, 1215, x squared, 20, 3 to the 3rd, negative 1 to the 3rd, negative 540, x cubed, 15, 3 squared, negative 1 to the 4th, that's 135, x4, 6, 3 to the 1st, all right, negative 1 to the 5th, negative 18, so the x to the 5th power, and then that 0 goes away, so I got 1 to the negative 1 raised to the 6th power. So it's going to be 1x6. All right? So this is expanding. Okay? All right? That's how to do those three. All right. So what I would like you to do is try, that's a 4 here. Okay? I would like you to try the next three. In the interest of the time of the video, I will provide the answer solution in the notes. Okay? So I'm just going to move on. Okay, I will provide the answer solution in the notes to these three questions. Okay. All right. Now let's get to this idea of combinations. Okay. Now, combinations. Okay. You learn about this in statistics. All right. They're all the ways where basically the order does not matter. Okay. Now, there is a combinations formula. This little thing with the exclamation point stands for factorial. So I just want to show you what that really means. So when you see the combination formula, 10 choose 3, what that means is, okay, 10 choose 3 is the same as 10 factorial over 10 minus 3 factorial, okay, 3 factorial. Let me clean that up a little bit, it looks really junky. I'm going to explain how to get it, but you're going to mainly use the calculator for this. 10 factorial over 10 minus 3 with a factorial sign and a 3 factorial. What 10 factorial means is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's like a little sequence of multiplication. Okay, now 7 minus 3 would be 7 factorial and 3 factorial. What is 7 factorial? 7 times 6 times 5 times 4 times 3 times 2 times 1. What is 3 factorial? Times 3 times 2 times 1. Now, what you can do from a math standpoint is you can eliminate the numbers that are the same. Okay? So 7, 6, 5, 4. Okay? So this is what you're left with. On the top is 10 times 9 times 8. 10 times 9 times 8. That's going to be 720. Okay? And on the bottom is 3 times 2 times 1 is 6. If I divide those, I get 120. Now, good for us. We don't have to do those calculations every time. I wanted to show you what they are. Now, let me show them in Casio. Okay? If you have a Casio calculator, okay, what you do is you go to Option. Okay? Option. Then you scroll over the arrow button of F6. Okay? You select Prob, which is F3. Okay? All right? Now, let's explain how what I'm going to select. Okay, what I want to do is I want to type my number first. So I want to type 10. Then I select F3 to get the combination. Then put the 3. Okay? That's how you can get 120. Like we started, this is so much easier. You're right. If you need to use the Casio because you don't have one of those, okay, what you do is you go into Casio, you hit Functions, okay, you hit Stats, okay, and you select NCR. Now, all you got to do is do 10, comma, 3. You get the 120. Either way, all right, you can get it. So that's 120. All right. So if I wanted to get this one, now that I have that set up, that's 8, choose 6. That's 28. If you were using this, I'd be at Functions, Stats, NCR. Okay, 8, choose 6. All right, 28. All right, and then 5, choose 2. I'm just going to go ahead and delete those. All right, 5, choose 2. Whoops, I deleted the parentheses. 5, choose 2. Okay, that's going to be 10. Okay, if you're using Casio, all right, 5, choose 2, 10. Okay, so what I'd like you guys to do, go ahead and pause your video briefly. Okay, and go ahead and all I want you to do is come up with those answers. Okay, I will show these. Okay, all right, 7, choose 2. That's 21. 11, choose 8. That's 165. And then 9, choose 5. Okay, I'll just do the last one in Casio so you can see. All right, all I got to do is select here, Functions, Stats, NCR, and type 9, choose 5. And it gets the same thing. Okay, so I just wanted to practice that briefly. Now, here is how we use this. Okay, all right, combinations in Pascal. Let me explain this. So the Pascal, as you did the triangle, you're probably thinking to yourself, Mr. Evans, do I have to draw out all that stuff every time to do this? And the answer is no. The combination stuff allows you, okay, it's part of the binomial theorem, okay, and the binomial theorem. And what that says is, okay, whatever your exponent is, okay, whatever your exponent is, you can put that exponent here and start out with choose 0, then go 7, choose 1, 7, choose 2, 7, choose 3, 7, choose 4, 7, choose 5, 7, choose 6, and once you get back, it's 7, choose 7. Now, watch this. All right, 7, choose 0, 1, 7, choose 1, 7, 7, choose 2, 21, 7, choose 3, 35, 7, choose 4, 35, 7, choose 5, 21, 7, choose 6, 7, and 7, choose 7. Okay, 1. And if you look at your Pascal's triangle, for the row of 7, you will notice the numbers are exactly the same. Okay? So, how would I do this one? All right? Now, all the same rules still apply. This would start x7, y0, x6, y1, x5, y2, x4, y3, x3, y4, x2, y5, x1, y6, x0, y7. So none of that changes. It's a way for you to get Pascal's triangle without having to draw out the triangle. So for this one, okay, so for this one, all right, the idea here is this would be 6, choose 0, 6, choose 1, 6, choose 2, 6, choose 3, 6, choose 4, 6, choose 5, and 6, choose 6. Okay? Once again, all right, 6, choose 0, 1, 6, choose 1, 6, 6, choose 2, 15, 6, choose 3, 20, 6, choose 4, 15, 6, choose 5, 6, okay, 6, choose 6. It's 1. So as you can see, all right, that would be the exponents, and then it would be x7, y0, x7, x6, y1, x5, y2, x4, y3, x3, y4, x2, y5. Whoops, that should have been 7. No, whoops, I started wrong. Sorry, 6, 5, 4, 3, 2, 1, and 0. Okay? So the binomial stuff actually works. Okay? So if you want to use your combinations and permutations, all right, you can. All right? So everything's the same. All right? All right? So what I'd like you to do, you can pause your video. I would like you to actually calculate these things. Once again, I will put the answers in at the end here for your problem. Okay? All right? So let's go on to these. It says find the fourth term, okay, of these of this. So what I'm going to do, it's going to make this a lot easier. Okay? I'm going to put out my 6, choose 1, 6, choose 2, 6, choose 3, okay, 6, choose 4, 6, choose 5, 6, choose 6, okay? Now, all right, so what else is that going to be? All right, x to the 6th, 4y0, x to the 5th, 4y1, x to the 4th, 4y2, x to the 3rd, 4y3, x to the 2nd, I made a mistake here somewhere, 6, 0, oh, I didn't start with 0, Sorry. Sorry. Travis is tired at the end of the day. All right. 0, 1, 2, 3, 4, 5, 6. All right. Y, 4. X, choose 1. 4y, choose 5. X, choose 0. All right. 4y, choose 6. Okay. So you can do this a couple different ways. If you want to type it all in, you can. 6, choose 0 times 1 to the 6th power, which would just be 1, x6. Okay, all right. 6, choose 1 times 1 to the 5th, 4 to the 1st. Okay, so that would be 24, x5, y1. Okay, this would be 6, choose 2, times 1 to the 4th, 4 squared, 240, x4, y2, 6, choose 3, times 1 to the 3rd, 4 to the 3rd, 1280, x to the 3rd, y to the 3rd. Okay, now, all right, somebody's asked, Mr. Evans, why'd you stop there? Because they only said to find the 4th term. So actually, I just showed you in the video, I only got to go 1 term, 2 terms, 3 terms, 4 terms. I don't have to go the whole thing, okay? So on this one it says find the 6th term. So watch, C81, oh sorry, C80, look at the same mistake again, C81, C82, C83, C84, C85, C86, okay, C87, and C88. Okay, now, 1st, 2nd, 3rd, 4th, 5th, 6th. So I'm working with 6, choose 5, okay? All right, now, what are the exponents with that? All right, this is x8, y7, I'm sorry, x8, y0, x7, y1, x6, y2, x5, y3, x4, y4, x3, y5, and that's the only one that I actually care about, all right? So what that would look like, all right, is 8 choose 5, okay, cubed, okay, so what's my thing, 3x, all right, 2, negative 2y to the 5th. So if I type all that stuff in, okay, 8 choose 5 times 3 to the 3rd times negative 2 to the 5th. Okay, so I got negative 48384. Okay, x cubed y5. Okay, so that's my answer. Okay, all right. Okay, so what I like you guys to do is go ahead and do these. I will do these because this is the last part of our video. Our 8th term here, all right? So, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, sorry, x5, I3, C, 10, 6, x4, y4, C, 10, 7, x3, y4, C, 10, 8, x2, y6. Let's count these. 1, 2, 3, 4, 5, 6, 7, 8. Actually, I can stop right here. Okay. All right. So, what is this going to look like? All right. I'm going to have 2x to the third, 6y to the fifth times that combination. All right. So 10 choose 7 times 2 to the third times 6 to the fifth. Okay, so 7, 4, 6, 4, 4, 9, 6, 0, x3, y5. Okay, all right, go ahead and find the third term of this. All right, so I would start with C, 5, 1, that's first term, or 5, 0, sorry. Second, third. Okay, so first, second, third. This is all I need right here. Okay, so what would that be? That'd be x5, y0, x4, y1, x3, y2. Okay, so I would have C, 5, 2. All right, 1, x to the third, negative 4, y squared. Okay, so 5, choose 2 times 1 to the third times negative 4 to the second. 160, x3, y2. Okay, and we'll continue to practice that a little bit more as we go.